welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's Linode, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Struggling with broken pipelines, stale dashboards, missing data? If this resonates with you, you're not alone. Data engineers struggling with unreliable data need look no further than Monte Carlo, the world's first end-to-end, fully automated data observability platform. In the same way that application performance monitoring ensures reliable software and keeps application downtime at bay, Monte Carlo solves the costly problem of broken data pipelines. Monte Carlo monitors and alerts for data issues across your data warehouses, data lakes, ETL, and business intelligence, reducing time to detection and resolution from weeks or days to just minutes. Start trusting your data with Monte Carlo today. Go to dataengineeringpodcast.com/Monte Carlo to learn more. The first 10 people to request a personalized product tour will receive an exclusive Monte Carlo swag box. Your host is Tobias Macey, and today I'm welcoming back Maxime Beauchemin to talk about the impacts that the evolution of the modern data stack has had on the role and responsibilities of data engineers. So, Max, for anybody who isn't familiar with you, can you give a brief introduction?
For sure. Yeah. And thank you for having me on the show again. Excited to be here. So how to best introduce myself? I think at this point in my career, I'm probably best known for the work that I've done around Apache Airflow and Apache Superset. So I started both these open source projects when I was at Airbnb back in 2014 and 15. Since then, I went on to start a company called Preset, where we essentially offer Apache Superset as a service. For those not familiar with Apache Superset, it is very much a data visualization exploration platform that caters to like all of the business intelligence type use cases and beyond. And then talking a tiny bit more about my career. So over the past 20 years, I've been, a business intelligence engineer, data warehouse architect. By the time I joined Facebook in 2012, I believe is when we started calling ourselves data engineers internally at Facebook. And that's the title that followed me for much of the decade to come. And then I've just been building a lot of data tools. Like I really enjoy building tooling around data. So that's really my passion.
And in terms of your introduction to data, we've gone over that a couple of times in past episodes you've been on, so I won't make you rehash that. I'll add a link in the show notes for people who want to go back and hear about that. But as far as the topic at hand today, you recently had a post that was talking about how the modern data stack is reshaping data engineering. And before we dig too much into that, I'll also call out the previous articles you had done almost 5 years ago on the rise and the downfall of the data engineer. And then we also did an episode all the way back in episode 3 talking about defining data engineering, because it was still very early in the journey of data engineering being a dedicated role and being something that people would actually go out and get as their job title. So now, almost 5 years later, it's almost incomprehensible that that was even the state of the world at the time. So I'm wondering if you can just give your current working definition of what a data engineer is and does, given how much it has shifted since the last time we covered that.
Things have changed quite a bit right over the 4 or 5 years, and that's really what I was interested in that latest blog post. So I highly encourage people to even pause this podcast and read the post, because I think today we're going to talk about a lot of these trends and how they're shaping and changing the modern data team and the modern data engineer. But I think it's the definition of what a data engineer is at its core hasn't really changed, right? It's the practice of designing and building systems and processes for collecting, sorting, analyzing data at scale. At a high level, a data engineer is someone who builds kind of systems processes around data and metadata It's a super broad field, right? Like that touches just about every industry, every team, every department. One thing that has changed quite a bit, I think, over the past decade is just how mainstream data has become. So, 20 years ago, when I was a data warehouse architect, it was the craft of a very small group of people in the company to be kind of the librarians of the data in the company. It was very kind of focused and targeted to a small group of people to take care of that. And now it's like every company wants to be data driven. Every team's a data team. People are investing a lot in their data team and that kind of skills. So things have become much more mainstream over the past decade. And then there's been like new roles that have been kind of shaping up. So there's some specialization, some new tooling. There's some tooling that makes some of the things that used to take a lot of time now just kind of something that doesn't take time anymore. So it will be interesting to talk about all of these things and all these changes.
And to your point, at the time that we first visited the idea of what is data engineering, it was still very much a low level operation where you had to be, as you said, well versed in the mechanical aspects of how data was laid out on disk, how the processing engines were going to work with it. Whereas now a lot of that has been pushed into the software layer. You don't need to think about it. You just say, I want to take the data and put it from point A to point B. There are services to do that. You don't need to think about all of the retry logic and error conditions that go into all of those things that wasted a lot of time and caused a lot of headaches. So I'm wondering how the growing availability of these data infrastructure services and the utilities that are built on top of and around them have shifted the foundational skills and knowledge that are necessary to be effective as a data engineer, and some of the ways that new and aspiring data engineers should think about spending their time and energy to actually break into that role.
There is a lot in this question to unpack. One thing is like the rise of the services that automate a lot of what a data engineer used to do. So on one front, there's these cloud data warehouses commoditizing kind of the database administrator type workloads, right? Even like the infrastructure load of the data engineer. I think in the rise of the data engineer, I talk about like, hey, some people include the infrastructure work of like setting up your data infrastructure as part of the data engineering role. And I think like that as definitely that with the cloud services that exist today, you don't need to go and kind of set up your own data warehouse, right? Like what all you need to do is kind of create a Snowflake account, a BigQuery account, and you're up and running fairly quickly. You pay as you go, right? You don't even have to necessarily size and kind of grow your cluster based on needs. Like all that stuff is done for you. That does mean though that there's still a burden around provisioning, like choosing the technology you're going to use and giving access to people. And then procurement, right? Like making sure you're choosing the right thing for the right reason and perhaps containing costs in some ways, or monitoring costs is becoming maybe more of a concern over time. There's another part of like the squish in some way of like on one end, right? Like the data engineer doesn't have to do some infrastructure work, maybe doesn't have to do as much of the scripting to hoard data. We're in a phase where like data warehousing is like a lot of it is about hoarding the data from all of the different systems and subsystems in your company into a central place. Nowadays, that means getting a bunch of data from your SaaS services, right? A modern company uses hundreds of SaaS services to operate, whether it's around, recruiting or customer CRM type things. In all areas of business nowadays, we use, targeted specialized SaaS systems, right? Whether it's payroll or pretty much in all areas. So bringing all this data, hoarding the data to the data warehouse is also something that's getting commoditized by tooling with things like Fivetran and Meltano and Airbyte. It's becoming easier to bring all of the data into a central place. So then there's a little bit of some workload is like setting that stuff up, making sure it works, monitoring these things and getting all, the procurement and the operation and the selection of that tooling is still big. Another area that we've seen changes is like the rise of the analytics engineer. That means now we have a data analyst who speaks SQL and knows Git pretty well. So that means they can start automating some of the T and ELT, right? So these people are able now to kind of solve their own problem and automate their pipelines. So that pushes the data engineer a little bit further away from this. So back to your question now, what does that mean in terms of like what skills do you need as a data engineer nowadays? I think it's an interesting question, right? I think like there's like question around specialization, like how broad do you want to go? Do you want to be more full stack, right? And be able to cover some of the data analyst to data infrastructure spectrum, or do you want to really focus and be the person who manages core data sets? There's also an area that seems to be just as complex and as kind of very still well attributed to data engineers, all the streaming pipeline. So this area, clearly, if your company needs to have streaming data pipelines, stream data processing, clearly, I think that stays under the realm of specialty of the modern data engineer as well.
With the introduction of these managed services where a lot of the work to set up the foundational data platform is just sign up for the service, put in the credentials, do some of the integration work, where that starts to sound a lot more like an infrastructure engineer than a data engineer responsibility. And I'm wondering what you see as the potential for at least some of the more service and infrastructure level work to be pushed into the domain of the DevOps engineer or the platform engineer, and less so in the realm of the data engineer, where the data engineer is maybe just the one making the selection of which tools to actually purchase and integrate, and less so of doing that actual integration work.
I think that's clear, right? Like we can kind of hand that over to the infra or cloud infrastructure team. They can handle it just as they handle other systems and pieces of infrastructure that they do handle. So that means the procurement process and even doing like security review, right? Is that tool matching our security type requirements? It's SOC 2 compliant, so they can be done in tandem or even led by your normal infra cloud infrastructure team. I think that in terms of like wiring all these things together, so we buy all of these services and tooling, and there's still like a responsibility of making these things work and then tying them together, right? Like, so I think that's true of infrastructure in general. It certainly is true with data infrastructure too, right? It's not just like buying Fivetran and DBT Cloud or whatever, or Astronomer Cloud, and then getting these things to just be like, okay, we've bought them, now we're done. So you still need to go and make these things work very well together. So there's like, metadata integration. There is essentially like just the duct tape and the chicken wire that's required to get all these things to work together. And I think the reality of the modern software engineer, just as much as like the modern, data engineer, is to get all these services to work well together, and then to take, all the business rules and the things that are specific to your company and put those and make sure those things are reflected in those systems.
One of the big themes in the idea of the modern data stack on all the different services that are becoming available, and the sort of areas of focus for data engineers and data product managers, is the idea of democratization of data, where you want to make data access more universal throughout the organization. You want to lower the barrier to entry, lower the level of sophistication that's necessary to be able to actually explore these different data sets that are powering the business. And in your post about the downfall of the data engineer, you called out the pressure on data engineers to maintain control with so many different contributors with varying levels of skill and understanding. And I'm wondering how you see the modern data stack balancing some of those concerns of giving everybody access to the data, empowering them to actually ask and answer questions, but at the same time not overwhelming the data engineer or not introducing sort of uncontrolled manipulation of the data in a way that actually causes there to be invalid assumptions based on the unknown quality of the data sets, or people who are creating new data sets without necessarily understanding what the original context was.
Yeah, so I think like if we think about this problem of if we give more access to more things to more people, just in the abstract, there's this danger of like people getting lost or shooting themselves in the foot, and I think that's a general problem. When something becomes more accessible to more people, there's a risk that it might be misused or misunderstood. So a big thing is the education gap, right? So do we make sure that we provide resources for these people to use the tooling right? And is the tool well structured and organized to provide all the context that the people need to succeed in what they're trying to achieve with the tool? So that probably mean one big thing is like metadata accessibility, right? So if you're building a dashboard from a data set, like how do you know all the context on this data set? Like, is it fresh? Who's the owner? Is it reliable? Is it certified? So I think some of these questions can be answered through the use of like good metadata and metadata management, and maybe like data dictionary, that kind of that space of, call it data graph or the metadata graph, understanding where is it coming from, who owns it, how reliable is this, who are other users of this data set, right? It's very popular and used every day by many of your colleagues. Your colleagues is probably, reliable. So that's like somewhat like beyond the tribal knowledge of going to the Slack channel called data questions and asking people like, hey, does anyone know about this data set and whether I should use this? Metadata accessibility is important. Educating your workforce. So at previous companies, we had programs to make sure that we push data literacy forward internally and make that accessible to just about everyone within a company. So at Airbnb, we had Data University where we taught, and I'm sure the program is still going on, maybe has changed over time, but my memory of it is we trained people on the tooling that we had, and there was like a progression of like, learning Airflow 101 and Airflow 201 and Airflow 301. There was also classes around data structures and the tables and the data sets that are most popular. And then just also like orientation of like, how do you ask a question? How do you find out what the data set you might want to use or might not want to use is? Similarly, at Facebook, there was something called Data Camp, and that was a little bit more, instead of being a series of classes, maybe with a commitment of a few hours a week. So that was the approach at Airbnb. At Facebook, I believe it was a full 1 week called Data Camp, and you would just almost kind of check out of your team for a whole week and then go sit through a bunch of classes. And it was like classes and exercises too, right? So they would ask some questions, get little projects, and play, data analysts for a whole week, which was pretty exciting. And they made it pretty fun too, where you would learn about the data sets. You would go and answer some really kind of key, intricate questions of like, hey, how does engagement work for different age groups? And are teens as engaged on Facebook as, your different groups of people? And then go and run your own analysis and learn about all the tooling that we had available internally. So there's this education gap. I think that's a big one. There's for the tooling to show more context. I think that's one way to help with that. I'll open up on like the topic of, call it data literacy or call it democratization of access to data. There's some bigger topics there. Like, do we want to democratize the entire analytics process, right? Do we want to make it possible for more people to write pipelines, for more people to go and instrument more events in application, for more people to go and define, business rules and things like that too? So I think the answer is yes. And then the question is like, what are the right set of guardrails and education we need to enable more people to do more of this?
Yeah, the democratization is definitely something that's worth kind of enumerating, where it could just mean giving people access to read it. But as you said, maybe you want to be able to give everybody access to write their own pipelines, to be able to build their own data sets that power their specific segment of the business, where one of the areas that's most recent that's seeing a lot of attention is the idea of the metrics layer, where you want to bring the business users in to understand the definitions of what that metric is supposed to mean semantically, and some of the ways that the data that we have can be used to actually formulate that metric, because the sales manager is more likely to know what the actual semantics around a conversion should be versus a data analyst or a data engineer, because we're working at the layer of the data, so we can see, okay, these are all the numbers, these are the different events that tie together. But from the business perspective, what does it actually mean to be a conversion, and how is that being used in the data? So we want to make sure that everybody's working together on that. from the pipeline perspective, maybe we have the core set of data pipelines that are kind of protected and you don't just grant access to everyone, but from that base set of data sets that we're pulling in from the application databases, from Salesforce, whatever it might be, we then want to be able to give people access to build their own downstream pipelines, downstream data sets. But to the point of guardrails, maybe we say, here is the kind of cookie cutter template of your DBT model to say, these are the core data sets you're able to pull from. Here is the initial set of operations to build a new transformation or build a new table so that it's using maybe the agreed upon vocabulary as far as column names. But you can now go and build some other view on this data set that you can consume in this dashboard. So you have kind of the templated out set of steps in the pipeline, so that all ties together with your kind of paved path. And then if they go afield of that, then they're kind of on their own, and you make no guarantees about the validity of their data sets that they're building.
Yeah, I mean, I'm interested to talk about like the metrics layer and like what it's after and what's novel about it and what's maybe so not so novel around it too. Because like, if you go back to the original data warehousing books that are 25 years old now, so the Ralph Kimball books, the Bill Inman books, it was always about metrics and dimensions. It was about conform dimensions, conform metrics, conform facts, getting consensus, defining these things very, very well, having these things be a reflection of the business. So I think like these ideas are not new. Like there's even like metric centric data modeling, like to say like, oh, the metric is the most important thing, at the heart of data modeling, or even from a data governance standpoint, I think it does kind of make sense. But really, I think what it's screaming to me, looking at these metrics layer and, different entities and people, companies kind of emerging in this space, like talk about different things when they say metrics layer too. But I think some common things and themes that we see, one is like beyond the DBT world of templated SQL, like we need higher level abstractions that maybe come with more constraints and guarantees than just like your raw templated SQL. So templated SQL is too freeform. Anybody can do anything. It's kind of the far west. So maybe the metrics layer is a little bit more prescriptive in what you can and cannot do, and how you have to define, say, ownership of things, or how things are derived, or how things like time window, are expressed more semantically instead of like writing like these more complex, unreadable mountains of SQL. So I think there's like this higher level abstraction with more constraints and guarantees. One thing that makes a lot of sense to me that people are not necessarily talking about too much is this idea of like more entity-centric data modeling. So when you think about like metric-centric data modeling, that means like, hey, we're going to make the metric the kind of unit, that really strong entity in information architecture around how we manage data and metadata, right? I think that makes sense. Like if you think at Airbnb or like bookings, bookings is a really important thing. Let's define like who owns certain like subsets of dimensions around how bookings are defined. And then we all need to align on a definition of this stuff. I like entity-centric data modeling, which is like when you think about like the Kimball book is all about like dimensional modeling, which a dimension is an entity, right? So it is very much entity-centric data modeling. I like to push this idea more forward and say beyond dimensional modeling. If you look at like feature stores nowadays that are more emerging in the field of like ML type area and feature engineering, I think it's really interesting to bring a lot more metrics to inside dimensional modeling, or call it entity-centric data modeling, to bring things like, 7-day visits and 7-day clicks and 7-day page views and 28-day, to pivot these metrics inside these entity-centric data sets. So that's happening quite a bit in the fields of ML and, historically in dimensional modeling. Going back into like the metrics layer, I think to me it's a little bit of a misnomer, because it's still like metrics are not useful without dimensions, right? So it's like we still live in a world of like metrics and dimensions. I guess now we're just looking to add like more governance kind of construct and ideas like around the metric. And then these higher level like less SQL and more YAML. There's like kind of this tweak of like, oh, let's be more configuration driven and less like kind of code or declarative, like transformation, low level transformation. Like let's operate a higher level a little bit, which I think is a great idea, something we could talk a lot more about.
Are you bored with writing scripts to move data into SaaS tools like Salesforce, Marketo, or Facebook Ads? High Touch is the easiest way to sync data into the platforms that your business teams rely on. The data you're looking for is already in your data warehouse and BI tools. Connect your warehouse to High Touch, paste a SQL query, and use their visual mapper to specify how data should appear in your SaaS systems. No more scripts, just SQL. Supercharge your business teams with customer data using High Touch for reverse ETL today. Get started for free at dataengineeringpodcast.com/hightouch. Yeah, to your point about operating at the higher level, one of the other interesting things that's been happening lately is the reemergence of these visual pipeline builders and low code / no code solutions where, maybe 10, 15 years ago, it was the world of, SQL Server integration studios and Pentaho, and everything was a drag and drop builder for defining your pipelines. And then with the advent of Airflow and the series of tools that followed it, it went back to everything is software. So it was software defined pipelines. So you needed to be able to write code and reason about the flows, and with the, MapReduce world of Hadoop. And now we're starting to build back up to this higher level of you can, take these visual elements, drag and drop them together, but then you have a way to actually drop down into the code layer. So I think it was Prophecy.io is one of the interesting entrances in that space where you have this visual mapper, but then when you want to actually dig in and maybe tweak things specifically, it actually generates the Spark code so that you can modify it yourself if you have sufficient knowledge. And so it's an interesting world where we have this kind of hybrid of low-code visual builders, but also the ability to drop down into the software level.
Yeah, it's really interesting to see these cycles too. I think both use cases are valid. I think like one realization, as the person who originally created Airflow, was like the pipeline world is like too complicated to kind of express and version and diff and review. It's so complex that it has to be represented as code at a certain level. When you start getting into like those GUIs and you try to do like source control type things that now are kind of a given, right? Like reviewing a pipeline, seeing what it looked like before and after, and forking and testing and CI/CD type things, like that stuff to me feels like as you go up the level of complexity, there's more need to be in that very kind of version control and as code environment. We also see like infrastructure as code, right? Like is also a movement and seems to be pretty well settled. There's tension there between like declarative and templated too, right? Like you express it as YAML, and if so, like how parameterized it is. And I've seen like a lot of YAML with a lot of logic in it, to a point where it doesn't feel like a static declaration of anything. It's very much more like code. So yeah, there's that tension. To me, I like the idea of like being able to have it both ways. So if you could have, the drag and droppiness of say Informatica and code orientation of something like Airflow, and have bi-directional workflow and being able to, pivot from one to the other and vice versa. Maybe that's the best of all worlds, but if you can just have it one way, it probably should be code, right? Like, I don't know, at a certain level of complexity, like these GUIs did seem to break down pretty intricately.
Absolutely. Yeah. I think that, as you said, if you need to go one direction or the other, it should be software, because at a certain point, you can't express the necessary logic in these constrained environments without having a very long iteration cycle of needing to say, okay, well, now I need to, go in and define a completely new visual block with some different input types that will map to the specific use case that I have. And then, you end up with a proliferation of blocks that are very similar to each other with slight tweaks. And so then it's just a different explosion of complexity where you'd be better off, having just defined a function that it takes a few parameters and, does these different conditional steps.
I think the best one that I've seen in terms of the best GUI that I prefer was the ab initio. It's not well known because it was very kind of special purpose and I believe very, very expensive, but it was very good in the visual drag and drop realm. And you could go pivot from code to visual to code bidirectionally pretty well. And then the parallelism specification, like the way that you could monitor the pipeline as it executed, was pretty great. You could see the visual flow of rows through intricate, transformation phases. So it felt a little bit like when you look at a query execution plan, from a complex, parallel database, you can kind of see all the blocks and how the different phases of your query, they kind of just expose that as an API. So I'm going to have like a group by, and I'm going to have a parallelization phase with a round robin. So you could define all these things very, very well and visually. And for me, it helped me early in my career to think in parallel. It's just the fact of seeing it and seeing the rows flow through and seeing declaring the parallel phases in the computation, really helped me understand data processing on distributed architecture early on because the visuals were so great.
Another element of the kind of guardrails, and you hinted at it earlier, is the idea of data governance. And that has also gone through a few different shifts where, earlier on it was a very sort of process-oriented manual endeavor where you had to have the data dictionaries and you said, these are the different data owners. And, maybe you had very coarse-grained access layers to say, you can only access this data set if you have this role in the LDAP system. And now with more code-driven and more flexible data systems and layers on top of that, thinking in terms of things like the introduction of tools like Immuta, which have more data sort of attribute oriented access controls versus just role based access controls, and some more of these flexible metadata layers to be able to understand as the data flows through the systems, these permissions need to flow with it, and being able to do sort of just in time access control where somebody wants to query a given table, but it has maybe somebody's address in it, so that you need to request access to it, and then that propagates to somebody else to say yes or no, rather than having to, go through a very manual process of trying to, submit a request to the IT department, waiting for them to turn it around in a week or so before you could run the query. And at that point, you've forgotten what you were trying to figure out. We can have these more flexible processes to manage data access so that people are constrained and that they're not just going to query everything if they don't have the necessary context or they don't have the necessary access. But in the cases where they do need to be able to run a query across a set of data, they can do so. Another interesting element of that is some of the more sophisticated sort of data privacy algorithms and cryptographic algorithms to be able to actually run queries on encrypted data without ever having to actually decrypt it in flight, to be able to do aggregations, but you don't ever actually see, the individual values. I'm curious to get your thoughts on some of the more modern sort of data governance aspects of how that plays into the data engineering role and some of the ways that also manifests in this sort of data democratization play.
There's many things to unpack here. One topic is kind of inheritance in the data schema or data access policy, right? So you mentioned data governance, and to me, there's subfields there. One is data access policy, like who can access what. And then there's data governance, more like who created what, who owns what, who's responsible for, say, the change management, the SLAs around a certain data set. So let's get into the more data access policy. I think it's pointing in the direction that if the database is aware of the data set graph, right, like which column is coming from where, then you can apply good inheritance kind of scheme into data access policy. And there seems to be value in that. It's interesting to see with ELT kind of winning pretty significantly, right? A lot of the bulk of the batch processing nowadays written in SQL, and it's done by the database engine. So that means the database engine should be able to track the provenance of any given column and data set and have some inheritance rules around that, right? And then databases like Dremio, for instance, are baked the transformations and the derivatives. I think the database is aware of where things are coming from. And I think there's a need for that. So that means maybe, over time, what we see is the database engine being very aware of the data set kind of semantic, right? So whatever is done in something like DBT inside the database knows about and surfaces that information. there's a lot you can do with that beyond just data access policy, right? There's like aggregate awareness, right? I could ask a question to the database and it would be like, hey, I know I have an aggregate that's fresh here that will better serve your query. So it's a derivative data set that I know about that you don't know about that I'm going to use to answer your query more efficiently. So I think like we will see the rise of database engines that are aware of the ELT or the transformation semantic and leverage that for all sorts of consideration. And probably is Dremio the only example I can think of that? I mean, Vertica kind of does that with projections, Dremio with reflections, but it's aware of different, maybe perhaps like projections or definition of the same data set. That's one thought. I don't know if I want to get, again, there was two aspects of your question. I'm kind of tempted to go in the data governance. That's more kind of ownership, validity, SLA, SLO type thing. But that's a very large unsolved problem right now that I think like a lot of the interest in data mesh currently are around the fact that the data mesh is talking about data governance, like who owns what and what is private and what is public in terms of data sets and what's the API to the data warehouse and what are the guarantees, like treating data assets as, and they call it data products, right? Like treating your data sets like they're little products with little kind of API with dual binding contracts around them. So I think that's an interesting area where we, haven't figured out as an industry, the answers there. Interesting parallels in this area with like microservices in the DevOps world of like, a microservice is like a really kind of clear contract and service. There's a question of like, could we have like data marts or data sets, some similar kind of contracts and guarantees in the data world around sets of data sets.
In terms of the actual data engineering position, as the usage of data has become more widespread, more data sources have become available, it's easier to actually get a data infrastructure set up with all these different services. It has caused an increase in demand for data engineers, which has made it difficult for companies to be able to actually hire for it because there are so many opportunities out there. And I'm curious what your sense of the sort of order of dependency has been in the sort of rise of the modern data stack and the demand for data engineers as to which has driven the other more prominently.
I think on one front, with the analytics engineer, as this materializes, and if we can get enough people that have those skills of like the analytical mindset and kind of the curiosity of the data analysts, and that for like someone who's like vertically aligned, right, that sits in a product team and wants to solve problems with data while being able to write pipelines and check them in source control and have decent kind of data engineering hygiene, I think maybe that creates a new need that removes some of the load and the pressure to have so many data engineers. And the fact that they're vertically aligned, I think their odds of succeeding is probably better than a data engineer maybe trying to do that across verticals. So that removes some of the pressure there. I think like as any discipline matures, it becomes more the essence of itself, right? So everything that is automatable in the role becomes, served by tooling and by practices. And what is left is the things that cannot, be solved like with a single solution or like the kind of one size fits all type of solution. Like, what does that mean in the world of the data engineer? What's the essence of it? Once everything that is automatable is automated, I think there's like less and less left. Like there's probably a page to read from the DevOps movement there too. Like, there's still like very much a need for DevOps engineers, even like kind of 10 years into the DevOps move too. One question is like, what are some of the things that every data engineer does that are going to go away maybe in the next 5 years? Like what services are going to pop up? So there's like these common patterns in data pipelines, right? And then in the past, I've been talking about, I call it like parametric pipelines, which is this idea of like these higher level abstractions we were talking about a little bit earlier. So everyone does like sessionization, for instance, to provide answers around, clickstream analysis and segmentation, right? So we all do this stuff. And then companies, as they mature up, they build their own A/B testing framework that computes, p-values, confidence intervals, and does all sorts of magic and complex computation around subjects and experiments and metric sets and all this stuff. So that's another one. I've seen people build and rebuild cohort analysis frameworks, and I think all of these we're going to see a company maybe or people or open source projects or abstractions that help people solve these problems without having to reinvent the wheel, so that every single company is kind of building essentially a variation on the same theme. Like, I would love to see these abstractions coming into existence so that next time I need to do sessionization, I can just download the package and solve that problem. We're not quite there yet, right? Like, I think we might see Airflow DAGs or Airflow libraries or DBT projects as reference implementation. But we're in the phase where it's even hard to find some good reference implementation for the things I talked about, right? If I go today, I'm like, I want to write my A/B testing framework, or I want to do some sessionization, what are the resources? You'll probably find some reference implementation that, if you're lucky, you might be able to reuse tiny portions of it and kind of bend into submission to get to where you need to be, right?
Yeah, and to your point of the selection of these different, pre-built packages, but also at the level of the different services that are being built and composed together, that has definitely become one of the responsibilities of the data engineer to say, okay, do I want to use Fivetran? Do I want to use Stitch? Do I want to use Meltano? Which data warehouse do I need? There are multiple offerings for each of these different layers of the stack. And so a big part of it is just tool selection and integration of those systems. And I'm wondering what you have found to be some of the useful strategies for approaching that selection process and being able to understand how well each of those different layers integrates together, some of the potential edge cases that might come about where, maybe I want to use Fivetran, but it doesn't work with Firebolt yet, kind of a thing, and being able to discover some of those edge cases before you get too far down the road of trying to get it integrated and find out that it actually doesn't work yet.
The part of the beauty of the modern data stack, I think, as we try to define it, one of the properties that we've seen is the pay as you go and try at will, or at least try for cheap. So if it's pay as you go and you want to do a proof of concept, you're able to self-serve into that, where in the past you might have to spin up some infrastructure to do a POC, or to pay or deal with a vendor process and have an official POC approach, and then the POC become an institution where now you have to involve 3 or 4 vendors. If you want to do a horizontal or vertical kind of integration through it too, you would have to involve multiple vendors for each layer and then align them, and then the combination just becomes really heavy. So at least now I think you can go pretty easily and try, if you could go from having nothing to having a pretty decent proof of concept with a kind of full stack integration pretty quickly. So if you want to try Fivetran today, I think it's pretty easy to get started and to get some data starting to flow. And similarly, I think with reverse ETL or some of these things that used to be very non-trivial, then you probably want to, talk to peers, similar companies, tap into the collective wisdom in terms of for people that are kind of like you, and then make sure it works for you. And hopefully you can get going. I think our story with reverse ETL at Preset is we're hey, do these tools, we need to send data back to HubSpot, some product analytics back to HubSpot. How are we going to do this? I was let me just try one. I'm just going to try high touch. And within, it's 25 minutes, I was connected to my database and sending data over, and everything was working pretty well. And we only needed one integration, which fits under the freemium plan. And we're okay, well, problem solved, So build confidence very quickly. And I think that's where the more old school vendors need to worry a little bit. It's for this generation of people, we want to self-serve, we want to run our own POC, and we want to get time to value down to sub 1 hour. And that's just not compatible with the more traditional sales cycle. You got to talk to someone, and they're going to ask you a bunch of questions. They're going to qualify you, and they're not going to be interested in selling you anything unless your contract value is going to be above, $20,000 or $50,000. So I think they're going to miss out on, the more traditional vendors are going to miss out on these opportunities. Kind of going to sneak up on them.
Another interesting element of wordplay is the idea of the modern data stack has gained a lot of popularity, as well as the idea of building a data platform. And I'm wondering if you see those as disjoint concerns or something where you start with the modern data stack and then you have to build the platform on top of it, and some of the sort of skills and responsibilities that are implied in each of those phrases.
I don't know what is the data platform and what is the modern data stack. They're like both a little bit unanswered, but like one way I would paint the picture for me is like my data platform at the startup that I'm part of is the collection of building blocks that we selected from the modern data stack and made work together with our business logic, right? So we pick a certain number of things, invested in making them work together. They're all modern data stack, I would say, like building blocks. And then our data platform is like the fabric or the mesh of services and business logic that we built on top of it.
Going back to what you were saying earlier about the role of templated SQL and the current prominence that it has in the form of DBT and a few other systems. But as you were saying, we need some higher level constructs to be able to have appropriate guardrails and appropriate kind of proofs around the validity of the workflows that we're trying to build, where SQL is a little bit too freeform because it's just text. It's parsable. You can make some assumptions about it, but it's very easy to kind of shoot yourself in the foot without necessarily having some advanced warning of that fact. And I'm curious what you see as the long-term viability of tools like DBT and the idea of templated SQL as a core workflow, and maybe some of the ideas that might succeed that is a more
fitted abstraction, maybe, right?
Yes.
And there's a question as to whether, DBT or Airflow or template SQL can be the building block of these higher level construct. And then I'd like to shoot that down. I think it's not. So I think like DBT or template SQL is a great way, I would say, to express ETL primitives. And by ETL primitives, I mean like you want to source from a data set, you want to apply filters, you want to group by, you want to join. So the ETL primitives or data transformation primitives are these simple things that are very, very well expressed in SQL. And with a little bit of YAML in there or templating, a little bit of Jinja and YAML and parameterization, you can achieve a lot. And it's great. I think like the rise of DBT. And by the way, like I would say like Airflow has templated like Jinja baked into it very deeply too. So you can achieve like very similar things with Airflow, right? So Airflow, I would say, is a superset of what you can do with DBT in many ways, right? So you can also have like all these other operators and your SQL operators and the Jinja templating. But I would say DBT does a better job at, showing you exactly just the subset of what you need. If all you care about is you have a single data warehouse, you're using just templated SQL. I think like DBT is just very elegant in terms of like coordinating a lot of SQL very, very well. It solves that in a very good way. So now if you want to build these higher level constructs, so let's just take one and we'll take, I don't know which one is the best one. We could take like the A/B testing framework, right? So you can go and write an A/B testing framework in DBT today, right? Like with YAML, you could say like go and define your metrics, your metrics group, where you have like your subjects, right? Your user IDs and all these metrics. And then what are your experiments and your exposure tables? And you can go and build all of that. But then what you're building is really hard to reuse for a variety of reasons. Like one is that as you become kind of logic heavy, you have a lot more Jinja than SQL. And then that just not is very expressive. Like SQL with a lot of Jinja in it, where every field list is a for loop on a collection of fields stored somewhere else. It's just like very hard to read and reason about. And it's not expressive enough to do that well, to have like these very dynamic pipelines. And then there's the other core issue, which is like DBT doesn't really solve, you're writing in a certain dialect. So you're only solving the problem for people who use the same dialect as you. Or if you're trying to say like, I'm going to write something that works kind of across SQL languages, then your template is going to become even more overloaded with Jinja, right? So you would not use something like limit or row num. You would use some sort of like more intricately complex abstraction on top of it. So I think like DBT doesn't seem like the right place to build these like higher level constructs, right? Maybe it's a great place to do a reference implementation and say like I have this simple DBT project where I do a sessionization. I'm going to share this in a GitHub repo and you can take it and reuse what you want and alter it to kind of fit your need, which might be the first phase. Like I think we need people doing that today so we can identify the patterns and share and talk about these things and have all these reference, like a good library of reference implementation so people can compare and try things. So it's a good place to start. Like Spark maybe seemed like a better place to do some of these things where you can write these more dynamic pipelines. It can be more dry. It's like more expressed as code. It seems more like a natural place for some of these frameworks to be in a higher level construct to be expressed. I don't know. There's a real question there of like, if you're trying to build these abstractions today, right, reusable kind of high level transformations, and I called them parametric pipelines or computation frameworks in the past as like kind of this idea of these higher level construct that solve certain like data engineering high level challenges. Like what's the right tool set if you're trying to build like a one size fits all solution, a reusable component that all companies can use to solve these problems? I don't know. I think I'd use Spark is probably what I would try to use if I was to work on that. Does that work for everyone? Like, does everyone has a Spark cluster or is able to run a Spark workload? Does it make sense for people to get data out their warehouse to compute it somewhere else and send it back in the ELT heavy world? Maybe. I don't know. It's unclear.
You just put everything into Delta Lake and then problem solved.
Put in the lake and let people write MapReduce to solve it, and we're done. Now, that's the way we used to do it a long time ago.
And then we're 20 years ago.
Yeah. But yeah, I mean, I would love to see a lot more of these like reference implementation, people sharing like, hey, this is how this team at this company solved, built a core analysis framework on top of Airflow. And here's, things you might want to try to reuse, right? And alter and make sense of. And you could have like more people sharing more of these things. I think it would become more clear what the different variation of on that topic are and make it easier for someone eventually to solve that problem once and for all for everyone.
There are a number of other sort of hot take topics that it would be fun to dig into. Maybe we'll have to slate those for another interview to go a little deeper on them. So I guess just quickly, in your work participating and contributing to the data ecosystem, what have been some of the most interesting or unexpected or challenging lessons that you've learned in the process?
So one thing that's interesting is to see how there's these cycles. And if you've been around long enough, in any given discipline, you'll see kind of new people come in and have a fresh take on these old problems without having necessarily the context of some of the failures in the past. I think that there's both like a beauty in that, right? That kind of the innocence of giving an old problem a completely new shot with a new environment and a new set of maybe tools and solution, right? The world has changed, so you don't think the right way, not necessarily think the same way about the problem, and can get really creative and fresh ideas. There's also on the other side this stupidity of kind of missing out and kind of this teenage like not being able to leverage previous experiences, or this innocence of like not missing out on learning from previous achievements and learning and struggles. So it's interesting to be that person sometimes that points out to, technologies or methodologies that, were born or existed, 10, 15, 20 years ago that went pretty far. Right? In some cases, like there's some of these efforts are very notable and solve not necessarily the same set of problems in the same way, but sometimes they would have optimized for a different kind of outcome or a different facet of the problem, and like much better on that facet than what we're doing now. So it's been really interesting to see kind of everyone rebuild everything on new premises. Like, everything's got to be on the cloud and everything is as a service and everything is as pay as you go and everything is distributed first. But in terms of like user experience and some of the expressivity of how we solve the problem, there's like shortcomings on that side as we optimize for new kind of constraints.
To close out the show, as the final question, in episode 3, when we took a crack at defining data engineering, we closed out with some predictions for the following years of what would come for the data engineering role. And many of those have actually been proven out pretty well. So you're very prescient in that. So now that we're kind of recapping some of those ideas and revisiting the definition of data engineering, I'm interested in what your next set of predictions are for the upcoming years.
I think there's a question around like how are data engineers going to work with analytics engineers, and that's a similar question I think to like what does a DevOps specialist, like how do they work with developers or engineers elsewhere in the company, and it's kind of transfer of like the vertically aligned versus horizontally aligned. But I think in the short term we're going to see a little bit of a struggle and tension and kind of identifying like the border between the two roles. And maybe the data engineer is going to feel like they're hurting kind of a little bit more reckless analytics engineers that, they want to solve business problems first. They're maybe oriented a little bit more short term and don't care about performance and costs and like naming conventions and best practices and hygiene, right? So we're going to see some tension there form until we can create like all of the tooling and the rules and the guidelines and the best practices that are required to make sure to keep these people in check and make sure that they're not, accumulating debt as they solve problems in their respective verticals.
All right. Well, thank you very much for taking the time again today to talk through the sort of current definition of data engineering. So appreciate all the time and energy that you have put into contributing to the data ecosystem and your continued sort of thought leadership, if you will. So always a pleasure to have you on the show. Definitely have to have you back again sometime. So thank you again for all of that. And I hope you enjoy the rest of your day.
It's been a pleasure. And I know there was a lot more questions on your list that we did not cover. So happy to come back on the show at some point and then push the conversation forward.
Thank you for listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.